Hello and welcome to I Owe You an Explanation. I'm Dan Ciruli. Hello and welcome to I Owe You an Explanation, the podcast where we take on a topic in technology, dive in, and give you an explanation about what it's all about. I'm your host, Dan Ciruli. I lead product management for Cloud Native here at Nutanix. And today I am lucky enough to be joined by a special guest, Steve Carter, one of the earliest employees from Nutanix, has been here a long time. And we're going to dive into distributed storage and AOS. What the name is now, what the name was then, and why we don't mention it anymore, but really what it's all about. Welcome, Steve.
All right. Thanks, Dan. Good to be here.
But before we get started, the way we like to get things going at I Owe You an Explanation is by taking on a technology that we all know, something that we use maybe at work, maybe in our daily lives, and talk about the before times. A technology that came in and really changed the way you live, the way you work. I've chosen for you video conferencing. You're not as old as I am, but you've been around longer than video conferencing has been around, or at least in its present form. Talk a little bit about how your life changed from, the days of phone calls and the days of, early WebEx to now.
Yeah, absolutely. Yeah. I mean, I guess even, pre-WebEx, it was conference calls, right? Where there'd be a number and a pin and, you'd dial in and everybody would talk over each other, and it didn't work that great, right? Unless you really needed it. But I mean, yeah, I think the biggest thing that it enabled is, for me is like working flexibly, I guess you could say, whether that's from home, whether, you're on the road, you can still join meetings and still stay connected. In fact, when I was at Salesforce, which is where I was before I joined Nutanix back in 2010, we had one team member who was remote, who was in Austin, Texas, and I even set up a little monitor in the office, and that was like pointed directly at his face. So when he was working, he'd have like a little.
So he was like,
present, like a little virtual presence that was like in the next to the where everybody else's desks were located and whatnot. So that was kind of my first experience really with more, I guess, than just video conferencing, but really bringing someone remote into the team.
Yeah. Do you think it has changed how you're able to collaborate with people who are far I'm compared to what it was like earlier in your career?
Yeah, absolutely. I mean, these days, the folks that I work with are all over the place, right? In fact, I'm in product marketing for NKP, and the technical marketing counterpart is over in Amsterdam, right? And we just had a video conference this morning, just like we were right there, and that would have been unimaginable, I feel like, back 15 years ago, or it would have been a lot more difficult.
Right.
That's for sure.
Everybody pretty much had to be in the same office.
Yeah.
Almost all the time.
Exactly. You might have like two separate offices that were sort of centers of mass, but then people would fly in for meetings and that kind of stuff.
How about personally? Are you a big FaceTimer?
No, with my parents. They really like to.
Do you FaceTime with your parents?
Yeah. They really like to FaceTime and see the family, see the kids,
that's a big deal.
So yeah, it is.
I remember the first time I saw FaceTime, that's literally what I thought is, this is invented for grandparents.
Totally.
Like the idea that grandparents who live far away can see their kids.
They don't even want to use the phone now. It's always like just FaceTime incoming.
Yeah.
So yeah.
Great. Well, thank you very much. That was a great dive into the before times. Now let's come to the present. Actually, we're not going to come to the present because I think in order to explain AOS to us, you're going to have to give us a little bit of a history lesson. You were early on at Nutanix. I said that before. Not just early on, you're employee number 33. The double-digit employee number is extremely low. AOS was, I think, the first product, right?
Yep.
It was the first thing. So you were back in the beginning. You remember what it was like. Tell us what problem they were trying to solve when they did this, and how AOS was created to solve it.
Yeah. So the problem really that they sought to solve was the storage problem. Was the fact that storage had become the biggest challenge in IT data centers. There was performance challenges. There were cost, capacity challenges. But I think the biggest thing was just complexity, right? Like most of the budget and the focus from the IT team ended up going into storage, or storage becoming the bottleneck in so many different ways. And so, the founders, one of them in particular was at Google working on the Google file system. And I think, had an epiphany that this technology could be used in the enterprise and could really change the way that enterprises run their systems and really simplify them and make them more cloud-like.
And I spent some time at Google too. GFS, of course, the underpinnings of so much.
Yeah.
How is that different than what was going on in the enterprise at the time?
Yeah, so the way storage worked at the time, the storage area network was really, the technology that had come to dominate IT storage. And it was basically a big monolithic storage array connected over, a pretty complicated fiber channel network is what it's called, right? Which is like a lossless, very high performance network.
Yeah,
right?
HPC, they used fiber channel.
Yeah. And it's used, it's still used today for, I look at it actually, maybe jumping forward a little bit, kind of like the mainframe where it's not going away, right? It's still going to be around, probably for a very long time. But it's, I think, gotten to the point where it's no longer the standard, right?
Right.
But that's because, I think HCI has led to a better way to build IT data centers.
Okay, so it was dedicated hardware for storage, essentially dedicated networking. Right. You weren't using fiber channel for
and it was a totally separate network, separate networking technologies. And so you would have like a whole separate team managing it as well. And it created bottlenecks. I think that's the other big thing. So much of the architecture and kind of engineering focus was figuring out how to scale the performance, given this centralized storage array. And as you added more servers and more workloads, now your existing workloads would take a hit performance-wise. And all of a sudden it became risky to add or change anything.
And what was different about the architecture of the way Google file system was built and then later AOS?
So the big difference is that it's distributed, right? That the storage is located next to the application. And so as you add more applications, you're adding more storage. And the way the real special sauce is the algorithm in the back end that keeps the data protected without causing hotspots, without causing, certain, sections of the storage, I guess, to become slower, to become bogged down.
Okay, so when you say running with the application, you mean literally on those same servers, those same physical servers, where you're running your applications. The storage is on the disks or flash in those servers.
Yeah, exactly.
Okay, so you're no longer using separate hardware, and then of course the networking is taking advantage of the network that's built into those servers as well.
Exactly. So it still has to, communicate between, the different servers, but now we can just use the standard Ethernet network. It was, the timing worked out that, 10 gig network connectivity was really becoming the standard at that point, right? Back in the kind of 1 gig era, it probably wouldn't have worked as well, right? And now we're up to 100 gig, plus, and it's become just, a non-issue. But the ability to manage
10 gig is consumer now.
Yeah,
People have that in their houses.
Right. I have a friend in Willow Glen who has 10 gig actually to his house. Like
I have 10 gig to my house. I only have a 1 gig network in my house.
That's amazing. Yeah. But and so I think what that did was it made it easy. That's the big thing, to manage the infrastructure so that IT teams can focus then on adding value on the applications themselves and less on, troubleshooting and so on.
And then the servers that it was running on, Linux boxes?
Yeah, just standard commodity servers. Right. And that was the whole idea, that instead of needing to go, buy a, and that was, I think, one of the big things with storage arrays is that they had very customized hardware. It was designed to be really durable, to, never fail, right? And so on, which means it would still fail. But the idea was to minimize the chances of it failing, and then you only had essentially two typically in the standard architecture. Where if one failed, now you only have one left, and you better hope that it doesn't fail, right? The difference, with this architecture is that it's duplicated across every server. So if a server goes down, you have 20 other servers that are still there to pick up the load, and so it makes it so that you don't need that super durable hardware anymore. The hardware can fail and the system will continue to operate without anybody noticing.
Right. And then I remember, I wasn't at Google yet in the early 2000s, but I remember very clearly people talking about, one of the amazing things was that they had built this really resilient, really durable software on commodity hardware. When at the time, people didn't do that. People turned, I also spent some time at EMC, right? And there used to be a joke that in Silicon Valley, when you got your first VC check, you then went and just wrote checks to EMC, to Cisco and to maybe HP at the time for your things. And Google said, no, we're just going to build this all on Unix boxes.
Right. Yeah.
So they started Nutanix. They wrote AOS. Which is not, it's a separate implementation from Google File System.
Yeah.
And what do they call it?
So that's a good question. I don't even remember what the first name was. I remember that for a while it was NOS, N-O-S, Nutanix operating system, and it had the kind of like nitrous oxide visual, we were trying to evoke this high performance thing. And then Acropolis was actually maybe that's one of the terms that a lot of people think of as, the Nutanix product. But Acropolis was really the hypervisor, actually. So, but then kind of long story short, was rebranded into the core platform as a Acropolis operating system, which then we've completely gone away with, and now it's just AOS.
And you said before HCI, for people who are listening at home and don't know this term, HCI, Hyperconverged Infrastructure.
Right.
Did that term exist before Nutanix, or did it happen at Nutanix?
What I recall happening was that it was an industry term that maybe was coined by Gartner or one of the analyst firms, talking about Nutanix and the other competitors in our space that were kind of, I would say, the fast followers of us, right? That were, saw what we were doing and saw that there was a bunch of potential there. And then we latched onto it. So, my recollection was it wasn't somebody in Nutanix that came up with that term, but, we latched onto it pretty quickly because, and what it came out of was converged infrastructure, which was the big, movement in the industry before us with VCE, right? With VMware, Cisco, and EMC partnered to say, we're going to take our storage array, hypervisor, and servers and package them into this SKU that you can buy all in one. And this should make it easier to manage, make it easier to buy and all that. Turns out it actually made it more complicated to buy and manage because if you wanted something customized, they'd have to go back and validate everything and it would delay things by months. So it turns out converged infrastructure did not, meet the promises. And so then this idea that taking it another step further and hyperconverging, bringing them actually together in the same box was kind of the evolution.
So one set of hardware, but it's running your virtualization, it's running your storage, and it's running your network.
Yeah,
all on that same hardware. And by the way, you didn't get into it, but it's Ethernet is the network, right? It's just standard Ethernet.
Yeah, exactly. Same network that's already there.
The same network that's already built into all those servers. And I've heard that while it wasn't necessarily designed for it, the first killer use case was virtual desktop infrastructure. Is that true?
That is true. Yeah. And one of the things actually that I really loved about being part of Nutanix in the early days was how I think originally there was this vision that we were going to take over the IT data center, that, every enterprise was going to be hyperconverged in the future, right? And that you'd have this distributed Google kind of across the globe. But we had to start somewhere. And there was this use case that was decidedly, not that exciting, right? Right? It's like like desktops being delivered over the network so that you didn't have to put a physical, actual physical desktop on each person's desk. But the problem was that the existing technology did not work well for it. So that was, I think, one of the reasons why it worked so perfectly was because the SAN was just not designed to handle hundreds of desktops all logging in and booting up at one time.
Everyone comes in and turns it on, and now you talked about bottlenecks before, like that. That is hitting that bottleneck.
Exactly. So the boot storm is what they call that. And boot storms used to be the biggest challenge in VDI, and I don't really think you hear about boot storms anymore, right?
Literally, never heard the phrase.
Yeah, and the big reason is because if you have, again, let's say 500 VDI desktops and it's spread across 10 nodes, now you just have, whatever it is, 50, did I do the math right? 50 desktops per node, right?
And versus all hitting the same storage device.
Yeah, so they're all just hitting that local storage controller versus all 500 going at the same, the same storage controller.
So they hit local storage, but there is resilience, there is duplication. automatically, I assume, so that if a node should fail, that data is preserved.
Yeah, exactly. And that's where it comes to like the difference of reads versus writes. So when you're reading data, you can just read it locally. That doesn't impact anybody else, right? And that's really one of the biggest benefits of storing the data locally is you don't have to go across the network for reads and writes. And then writes, of course, do need to be duplicated. And it has a really cool algorithm with the way that it actually in real time decides where to send the replica copy based on the load of the other nodes in the cluster. So if one node has a bunch of desktops booting up at once, the system will decide to send the replica to other nodes, right, that are less loaded.
Very cool.
Yeah.
Very cool. All right. So you've been here. What year did you start?
So 2011.
Okay. We're now in 2026.
Yeah. It's crazy.
15th anniversary coming this year.
That's right.
What's the coolest addition you've seen in those years? So started with AOS, still really, I think, kind of the core. What cool has happened lately?
Well, lately, I mean, my passion now is certainly Kubernetes and NKP. But truly, I think, I mean, in fact, I remember in the very early days when, we were all working at like when I joined, by the way, they gave, us a laptop with no hard drive. And they basically like, here's your hard drive, go install it. And then here's an Ubuntu CD. Like, hopefully you'll be done with that by lunch. And then
you joined as an SE. So everyone knows.
Actually, no, I was QA at the time.
You were QA first.
Yeah.
And I was done a lot.
Working on the test automation framework.
When we bring you back, we're just going to talk about your career.
There we go. Yeah. Sounds good. But, and so, it was like that early startup buzz. We're all excited about the future and whatnot. And I remember people talking about containers and how this new container architecture, I remember that Mesosphere actually and Docker were the big, the hot topics of the time, and how this architecture would lend itself perfectly to that.
Right.
Now, we were way too early to start getting involved, but it's funny how it's really come full circle. And we've gone with I feel like in a lot of ways what Google created that allowed them to create their search engine that scaled so well originally. And now Nutanix had created, this kind of storage version of that infrastructure for the enterprise. And then Kubernetes is then the compute side of that. And so now you have that
Google
full
had Storg for managing containers. And now the world has Kubernetes.
Yeah, exactly. And we used to always go pitch ourselves as Google for the enterprise. And at a certain point, we had to stop doing that because everyone was like, look, we're not Google. We don't run at their scale. That's too complex. But yeah.
All right. Well, this fantastic conversation. Before I let you go, we like to close episodes with a little thing we call What's Your Take? And I'm going to give you a topic. Give me a take. Is it a hot take? Is it a cold take? A lukewarm take? The take I want from you is Kubernetes is best for stateless applications.
Ooh, that is a cold take.
Ooh. Tell me why.
Because so Kubernetes containers themselves are stateless and they're designed to be able to fail and then another container will pick up the load, right? But every application has state of some sort, right? Even I just think of like Minesweeper. Like if you need to score the high scores, that's state. That has to be stored to a database somewhere. So I feel it's a little bit of a misconception that even though containers themselves are stateless, the actual app isn't. And there's another point actually I want to make really quick is on AOS, this is one of the things that I learned when we joined Nutanix, is the way that it was designed is actually very similar to how a microservice is designed, with this idea that anytime there's an exception or a fault, it kills the process and restarts. And another version of that service will then take over, rather than trying to handle every single exception and recover without failing, right? And so the fact that the storage layer itself is actually built in the very same way that the applications are being built in Kubernetes, I think, points to the alignment, I guess, of the technologies.
All right, I agree. Every application, you don't have an app if you don't have data. Every application is backed up by data, and eventually everything needs some state. Kubernetes has gotten really mature at handling that as well. Well, thanks a lot, Steve. Great conversation. Really appreciate you taking time out of your day to come spend some time. And I'd like to thank those of you who have listened to this episode. Really appreciate you being here. We will be publishing these regularly. They will go out everywhere you get your podcasts. And if you want to find them, you'll always be able to find them in Nutanix Newsroom, which is another great place to find more news about our products and what we're doing. So we'll see you soon, and we'll deliver more explanations that we owe you about the technology that really affects the way we work.